Hello, we're Team Landroids from Livingston, New Jersey. We chose beach erosion in New Jersey as a problem caused by climate as our research topic.
We are here to discuss the coastal erosion problem in our coastline communities. Beach erosion is destroying our shoreline, damaging our properties, and making us lose our tourism revenues. We don't have money for a permanent fix. Local budgets are constantly used for emergency sand replenishment. 60% of New Jersey residents live in coastal towns. The population triples in the summer. Many beachfront homes in New Jersey are worth millions, and they can be severely damaged by beach erosion. However, the maximum amount covered by the National Flood Insurance just isn't enough. Beach erosion is a constant battle.
Beaches are constantly moving. When waves hit the beach, they deposit some sediment and take some sand back into the ocean. Beach erosion is when there are less deposits of sand than what flow away. Coastal erosion can be caused by rain, storm surges, winds, hurricanes, nor'easters, and tides. When each factor is on its own, the result isn't that bad, but when combined, the effect can be devastating. NOAA has an archive of hourly buoy data with information such as wave height, wind direction, and wind speed. We can use this data to see what can be done to divorce our shorelines.
There are some environmental concerns with using these unnatural structures to protect the beaches. Our beaches in the barrier islands will naturally migrate inland, with sand drifting away and replenish itself over time. Armoring the shoreline with groins, levees, seawalls, and breakwaters, or even damming and cleaning up the river, will just rob the sand from somewhere else and affect the ecosystems and habitats. It seems that these beach protections are made for protecting buildings, not the beaches.
As a person who loves all the beach activities, I am torn. If we're losing the beaches, I have nowhere to sunbathe. Bringing in sand may bury the historical artifacts near the shore. There goes my beach diving. Whenever you put in those rock breakwaters, you kill my waves. By building those seawalls, I have no open beach for surf fishing. Besides, tourism is the second largest industry in New Jersey, producing $30 billion in revenue yearly. 70% of that income is from coastal businesses such as shops, restaurants, hotels, entertainment, and casinos. If we can't save our beaches, there will be no tourists and tax revenue.
There are federal fundings that can help restore our beaches. In order to qualify, property owners must grant public access according to the public trust doctrine. Typically, the federal government will fund 50 to 65%. The rest is paid by the state and local government. If the property owners do not grant the easements, we will have to use eminent domain to force some action and decision from some unwilling homeowners to save our coastline.
The Army Corps of Engineers, who works for the federal government, has recently completed a New Jersey beach replenishment project using a 10-year-old offshore dredging method. Both the Surf City and Long Branch projects cost over $71 million since 2006. The 2009 Long Branch project cost $9 million to rebuild 1,500 linear feet of beach with 725,000 cubic yards of sand, working 24/7 for 2 months.
This kind of periodic replenishment is like throwing money in the surf. Every 5 to 7 years, more sand is needed. There are new technologies that can help slow down sand's longshore transport and shifting, and help reinforce, stabilize, and replenish the beaches.
Commonly used methods are geotextile fabric to help the plant roots take hold, geotubes to help hold back the beach line and dunes, and overlapping scaled plates on ocean bottom to retain some sand. A floatable and removable wave dampening system could reduce the wave's energy, which was suggested to be used in a lagoon in Victoria, Canada.
However, what we need is a long-term, sustainable solution.
Our idea is to use some kind of submersible hydropower wave pump that can continuously use the wave's up and down motion to pump a sand slurry back to the beach so the beach can replenish itself. We evaluated various pump designs and found that a combination of an aspirator pump and a piston pump would be best suited to transport the sand slurry. This is very similar to a submersible wave pump known as the Cedo pump.
We used the data from Long Branch New Jersey Beach project to compare with an Australia Cedo project, which was currently used to generate power and desalinate the salt water. With extensive calculations, we estimated that 8 submersible wave pumps working continuously for 7 years are needed to replenish the same Long Branch New Jersey project. Over the pump's 30-year lifespan, our idea could potentially save $34 million over the current method.
These underwater sand slurry pumps are self-sustainable on wave energy, have no carbon dioxide emissions, will not affect the ocean view, have minimal energy loss using tidal and wave action, and do not disturb ocean life and could form an underwater habitat.
With everyone's input, these engineering solutions were presented to our Army Corps advisor, a beach town mayor, a beach erosion book author, and the Cedo wave pump manufacturer. We received very favorable responses that our ideas are feasible. By using renewable energy to work with nature, hopefully our ideas will help many coastal communities in the near future. Thank you.